So now I'm going to look at what is probably the most obscure and difficult thing to get right in KineFX, and that is the exporting of blend shapes. There is unfortunately very little help available on the exporting of blend shapes, and the help that is available is very obscure and would be almost impossible for a beginner to decipher. This is one of those cases where you'd get more information from the forum than you'd get from the help itself, but even then, if you're new to Houdini, it would be very difficult to decipher this. So this process is pretty complex. Part of this comes down to the way KineFX works, but most of it actually comes down to the way information is stored in FBX. I'll give a brief overview of how this works, and then we'll try and build a couple of HDAs in order to make it easier to export. So first, a brief explanation of what we need and why we need it. So we'll have a node in KineFX, and we'll say this node is our character node. We'll just assume that this is a node which is carrying all the information for the character. And what we want to do is feed the blend shape information from this node into another node in KineFX. To do this, we'll need three sources of information. The first would be the mesh. This will also be referred to as our rest geometry. This will carry the mesh, all its weights, and this is where we'll actually store the information for the blend shapes themselves. We will also store information like materials over here. Our next information will be in the form of the capture pose. This is essentially our skeleton, but the skeleton pose must be the same as the pose it had when the weights were added to the mesh. Other than the fact that the poses need to match, there is no other information required here. Our last path will be the animation. This will be an animated version of the skeleton, and any other animation will occur here. So with the FBX, we will store all this information. We'll store the mesh, we'll store the animation, and we'll store the skeleton. Most systems, this will be a black box, and everything will be dealt with via the export interface. The difficulty with KineFX is that we actually have a great amount of control over the information which we are sending, and because of this, we are actually splitting up the animation which we need to send for blend shapes in the network. On the one hand, we need the information for the mesh. We'll store this information in two attributes. We will need the name of the blend shape, and we'll need the name for the channel which will need to be animated for the blend shape. However, we also need the animation, and the animation will need to be stored with the other animation, so this will actually need to be stored on the animation branch. This will need references to our channels again. However, in this case they will be the channel parameters, and these will become the parameters we use to manipulate the blend shapes. We will also need a dictionary which will store the information required for animation. So essentially we need to create 4 attributes, and we need to create them in different branches of the network. So before this, we'll take a look at how these actually work, and to do this we'll take a look at probably the best resource in the help. This is from the examples and is the simple character blend shape example. So here we have the simple character blend shapes example. This is a cylinder with some animated deformation. We can enter this node, and there are 2 nodes within it. The first of these is our source rig, and this is actually an object level rig. Unfortunately, it is not a KineFX rig. We then have our SOPNet, and this is a KineFX setup, and this shows how blend shapes work in a rig. We start with an FBX character import node. We then have an attribute expression node which is connected to the animation output. This node is isolating the blend shapes. This is followed by a character blend shapes node, and this will extract the blend shapes and apply them to the KineFX rig. We finish with a bone deform node. This will give us our final animated rig and mesh. We can now look at some of the information from the FBX. I'll get a null so we can isolate individual paths. And we'll start by looking at our rest geometry, which is essentially our mesh. I can then select this null, and we can look at the geometry spreadsheet to see what attributes we have. Under point attributes, we have the points themselves, and we have the bone capture. So essentially we have the point positions, and we have the capture weights. There's nothing of import under vertex attributes. Next we can look at our detail attributes, and here we'll see our blend shape channel and our blend shape name attributes. We will also have the name for our mesh here. In this case, we can see that it is storing the names of the geometry as well as the bones here. Most of the other attributes are related to the capture of the skeleton. Basically, they're related to weighting. And if we scroll down to the bottom, we'll find two entries here with values for our blend shape attributes. Each of these represents a single blend shape, so this mesh has two blend shapes. The channel is the name of the parameter we will use to animate the blend shape, and the name refers to the blend shape itself. In this case, the parameters are both prefixed with the mesh's name, and in the case of the name, it is prefixed with default, then the mesh's name, and then the blend shape's name. So those are the blend shape parameters, which are in the primitive attributes. I can then move my null and connect it to the animation output. If I select the FBX export node and take a look at the information for the node, we'll see that there are no detail attributes showing. But if we take a look at the null which has been connected to the animation output, we'll find quite a few detail attributes. And in this case, we no longer have any primitive attributes listed. So now we can look at the geometry spreadsheet again, and in this case we'll look at the detail attributes. The first attribute is actually a dictionary, and this is for our clip channels. This is where we'll store the animation for our blend shapes. This will be followed by a clip info attribute. This will store the animation which is on the bones. We then have two float attributes, and these attributes have exactly the same name as the blend shape channels. These do not store the channels themselves, but store a current value for the deformation. We can use these parameters to control our blend shapes. To access these parameters, the easiest way is to use an attribute expression node. This node can also be referred to as the point node. When we apply this as a point node, it just gives us different default parameters. The attribute class will need to be details, and in this case we'd be working with a custom attribute. This will allow us to manipulate the channels for our blend shapes. The expression would need to be set to value to allow us to manipulate it. And in this case we're working with a float and not a vector. And this will allow us to manipulate the channel. And this will allow us to animate the blend shape stored in an FBX file. So we'll want to create these attributes, and then we will want to store them in an FBX file. But first I'll give a summary of the scene that I'm going to be exporting and how I've set it up. Before we work on blend shapes, we'll take a look at the scene which I'm working on. This scene consists of 3 geometry nodes. The first one is going to be used to create my mesh. The second one is going to be used to create the skeleton. And the third geometry node is my rig. So for the mesh, we're creating a simple example geometry. I'm creating a simple mesh with a sphere and a tube. These each have a material assigned to them. Each of these will have a name assigned which applies to the entire mesh. And in this case the name is FBX material name and not name. I then have a material network where I'm creating the materials for these nodes. And inside this network there are 2 principal shaders. The principal shader is the only shader which will work properly with FBX. And these are the shaders which I'm attaching to each of my meshes. I'm then merging this together, and you'll see that we have my FBX material name attribute. This will be used to assign the materials themselves, and then we have the shop material path attribute, and this will refer to my actual materials within Houdini. I have not named the mesh itself within this network. This is something which I could have done, but in this case I chose to name it as part of the rig. So I have created the primitive attributes I need to export my materials. I've then exported this as mesh.bgeo.sc. We then have the skeleton. I have set this up as a skeleton which can be exported to Unreal with a root bone that has been placed at the origin. So in this case I've created a simple line. I have then named the points appropriately, with the point at the origin, basically a translation in 0x, 0y and 0z, being my root, and then I've named the rest of them with the base as the bottom of my character, the body as the center of the character, the head to control the head, and the head effector as the tip of the head. We then add the transform attribute to the character. In this case I'm adding it with an attribute wrangle node. I'm creating a 3x3 matrix attribute, and I'm setting this as an identity transform. This transform will store each point's rotation, and this will turn it into a skeleton. So once again, if you want to convert a point into a joint in KineFX, you need to give it a name and you need to give it a transform. Since these are part of a line, they'll be parented in the order in which they're attached in the line, and therefore we'll have a complete skeleton. I'm then exporting this with a ROP geometry node, and in this case the file is called skeleton.bgeo.sc. Our final node is the Blendshapes. I start by bringing in my mesh skeleton files in with file nodes. I then add my name attribute to my mesh. There are a couple of nulls which have been placed after my file import and my mesh import. These purely serve as markers to show where the import ends. I'm then creating the weights for my mesh, and this starts with the bone capture lines node, and this is connected to my skeleton. In this case, I'm excluding the head effector from the deformation. I then have a tet embed node. This creates a tetrahedral mesh which stores the information for my skeleton, and this will store it as part of the volume of the mesh rather than as part of the surface of the mesh. If we look at this as a wireframe, we can see the volume of the tetrahedral mesh, and in this case it is easy to see where the bone is being registered as part of the tetrahedral mesh, as we can see the line of the bone being formed by points down the center of the mesh. And this line down the center of the mesh is the source of all the weighting information that will be calculated from the skeleton. We then have my bone capture biharmonic. This bone value will apply the information from the bone capture lines in the tetrahedral mesh to the surface mesh itself. This will give me my final weights for the mesh itself. We can then store the results of this in the stash node. This way none of the network before the stash node will be evaluated. Only evaluating the results in memory will make this network far more efficient, as we'll not be trying to reweight the character every frame. Instead, we'll only refer to the results of the stash node. This has then been defined as my rest geometry. This is the output for this branch of the rig, and this is my mesh output. We'll then start working on the branch for the skeleton, and we'll split this branch. The first branch will merely contain the skeleton. This skeleton needs to be the skeleton that is used to define the weights of the rig, and this will be referred to as our capture pose. This should be the default pose for your skeleton. The next branch will be for my animation. Here we have a rig pose node. This will apply animation to my rig. In this case it is some pretty ugly animation. This will terminate with our animated pose, and this is the point where we'll be storing all the animation for the rig. To display all of this, we have our bone deform node, and this will show what our final deformation looks like in Houdini. This node will give us a deformed mesh. We can then do some extra work on the rest geometry. So I'm taking the result of my rest geometry, I'm passing it through to this object merge, and then I'm creating a couple of blend shapes. And we can take a look at the result of these blend shapes here. There is a specific reason why I'm creating these blend shapes after I have done the weighting on the mesh. And that is, if I created these before we exporting the mesh and before we weighted the mesh, that would mean I'd be creating them before the stash node. This means that we would see no dynamic results from this deformation, and we would have to update the stash node to see the final result of our deformation. Having to update the stash node every frame would be counter to its actual purpose. So instead of passing our rest geometry into our deform node, we could pass the updated rest geometry from after our blend shapes into the deform node. This way I can animate my blend shape. Then, if we view the blend shape deform, we should be able to see the final result of the skeletal animation and the blend shape animation together. So this will give us our final rest geometry, and this will be used for our export. To see this, I can take a look at the dependency links, and we can see the flow of information within this graph. My mesh weights will pass down from my mesh file through the weighting process. This will pass to my blend shapes, and my blend shapes will pass information through to my object merge node for the export. We'll be using an FVX character output node here. The first input is taking our mesh, and the second input is taking the capture pose. I personally do not like animation to be in my default character rig, so I'm using the capture pose for the animation, and I'm then using a configure clip info node to create a default character clip for this character. The animated pose is also having its information set with the configure clip info node, and this is being passed into a ROP FBX animation output node. This will allow me to export the animation separately from the character itself. So that is our basic setup. I should be able to export everything except the blend shapes at the moment. Next we'll set up these blend shapes for export, and we'll create some HDAs to allow us to do this far more easily. We'll now create the actual blend shapes, but in this case I'm going to be creating a couple of HDAs in order to simplify the process. This way I only need to connect up a couple of HDAs instead of trying to set up the entire blend shape export process manually. We'll be creating two HDAs. I'll get a subnetwork. I'll then duplicate the subnetwork. The first of these will be used to define our blend shapes, and the second one will be used to control the blend shapes. I'll call the first one Blend Shape Create. I'll call the second one Blend Shape Control. I'll then bring up the drop-down menu and select Create Digital Asset. The name and label will both be Blend Shape Create. I'll select the directory, and this will be my HDA directory for the HIP project. I can then accept to create the HDA. I'll change the icon. This icon will become SOP, KineFX, Character Blend Shapes. I'll set the minimum inputs to 0. I can then go to the Input Output tab, and I'll rename both the input and the output as Mesh. Next I'll go to the Interactive tab. I'll then go to my Shelf Tools tab, and I'll go to the Content tab. And I'm going to update the tab schematic path. I personally prefer not to replace the Digital Assets folder, as I do not like to add more menus to the main drop-down menu. But I will add a subfolder to this, and this subfolder will be Rig, and then there will be a subfolder to that which will be Utils. I can then apply this and accept. I will now convert the Blend Shape Control node to a digital asset as well. This name will be Blend Shapes Control. I will save this within the project HDA directory. I can accept to convert this into an HDA. My type properties opens up in the interactive tab, so I'll start here. This will be digital assets, /rig, /utils. Next I'll go to the input output tab, and I'll set the input and the output to be animation. Finally I'll enter the basic parameters. Minimum inputs will be 0, maximum inputs will be 1, and the outputs will be 1. And I'll set the icon again with SOP, KineFX, Character Blend Shapes. We've created the nodes. The Create node will go with our blend shapes, and the Control node will be connected with our animation path, and it will be connected near the Pose node. I'll need a copy of the blend shapes node for each blend shape I create, and I'll attach these nodes to each of the blend shape paths. Since I only want to be updating one of these, I'll go to the second node, and I'll set it to match current definition, which means that this node will always update to the latest version of my HDA, and I will not have to edit it. I can then enter the first of these nodes, and I'll be adding 3 nodes to this branch. The first of these will be a pack node. This will convert our blend shape to pack geometry, and pack geometry is a far more efficient way of storing our geometry. I'll then turn off my path attribute, so that will be my initial setup for the pack geometry. Next I'll get an attribute wrangle node. This is where I'll create the blend shape attributes. And finally I'll get a visibility node. We do not want our blend shapes to be visible, we merely want them to be stored in the mesh, so we'll use the visibility node to hide everything. I can then exit, open my drop-down menu, and save the node by using Save Node Type. I can then enter the second node, and we can see that it has been updated. So we've set up the structure for our blend shapes, and we can test them. If I move the blend shape sliders, we'll see that nothing happens. This is because we're using packed primitives. I'll scroll up and I'll turn on Treat Packed Primitives as Shapes. So my packed primitives are currently working, but we do have a couple of issues. The first one is we're getting a warning when both of them are at 0. And the second one is that there is a slight snapping whenever we reach 0 on some of the shapes. We would of course prefer this to be a smooth blend. If we look at the error, it will say that the number of packed primitive inputs is less than the number of blend weights. Not all of my inputs are creating packed primitives at the moment. I'll fix this by unchecking the one blend shape per packed primitive option. This will mean that every blend shape is connected with a single input. If this is checked, every input will be looking for a packed primitive. My blend shapes are now working smoothly, and I no longer have any warnings. I'll now re-enter the blend shape node, and we can add our blend shape attributes. These will be primitive attributes. The first one will be defined by @ for an attribute, blend shape underscore name. I will initially set this to be an empty string. The second one will be @BlendShape underscore channel. These attributes will need a prefix of s to specify that they are strings, and we should now have the two attributes which we need to associate with our blend shape. I'm going to use a very simplified setup for these attributes, in that my name and blend shape channel will be identical. I'm not going to be setting up my name and my channel with parameters. Instead, I'm going to set them up using the name of the node. So for example, I could consider this node a smile shape, and I could rename it to smile. The shape could be considered more of a jaw down, but I'll call it smile for now. For the next shape, I'll simply call this node eyebrows. So the way I'm going to set this up is to use this parameter for the node to set both the blend shape name and the channel. Depending on your workflow, you may want to separate these, in which case you'll have to do something more complex. But for my workflow, I want this as simple as possible. We can now update our attribute again, and the first issue which we're going to have is getting the name of the parent node. The method I'm going to be using is a bit of a hack, but it works and it's one which I'm comfortable with. To do this, I'll open the type properties for the blend shape create node, and in the parameters tab, I'm going to add a string parameter. I'll then apply the changes, and I'll open up our parameters so we can see what we're doing. I'll call this parameter node name. The label will also be node name. This parameter is actually going to be hidden, and to hide it, I'm going to place a parameter in the hide when field. Since this is always going to be hidden, I just need a true parameter. So in this case, I'll check if 1 is greater than 0. The reason to do things this way and not use the invisible checkbox is that I want this to be hidden from the user interface, but I do not want it to be hidden in the parameters tab. If we check invisibility, we have no access to this parameter, and I prefer to be able to access parameters that I may be editing. I will then open the channels tab so I can set a default parameter for this. This value will be an expression, so I'll need 2 backticks, and the expression will be $OS. I'll just clear the hide parameter for a moment, and I'll make sure that we are actually setting this parameter. And it should have the expression $OS. Basically, this parameter will always store the name for this node. In my attribute, I'll create a string variable. I'll call this parent name, and we'll set this with a string channel, so CHS. We're looking for a parameter on the parent node, so this will start with .. and the parameter is node name. The blend shape attributes can then be set with the parent name. I can then save the node type for the HDA, and we can take a look at our geometry spreadsheet. Now if we look at the blend shapes node, we'll see that our parameters are not actually showing up. That is because this node is actually used to control the blend shapes and not to export them. For our export, we'll be using a merge node, and we'll use this to merge all the branches for our export together. If we look at the parameters for our merge node, we'll now see that we have our blend shape attributes, and we have 2 entries, one for the smile and one for the eyebrows. I'll then duplicate the null for the rest pose geometry. The first one will be our rest geometry blend shape display, and the second one will be our rest geometry blend shape merge. Then in the object merge node, I'll replace the blend shapes reference. This will now refer to the rest geometry blend shapes merge null. We've now set up the blend shape attributes. Next we can work on the controls for these attributes. So the next thing that we're going to do is we're going to update the Blendshapes node itself. I'll select the Blendshapes node, and there is a button on this node, and this is called Update Channel Names from Input. We will press this button, and the names for our parameters will now be the same as the nodes for their inputs. In this case, my Blendshapes sliders will now be referred to as Smile and Eyebrows. One thing to note is that we've not changed the names of the parameters. What we have created here is an alias. An alias is an alternate name for a parameter, and we are able to refer to this parameter by both its name and its alias. In this case, we're going to use our alias to associate the parameter's name with the blend shape and the blend shape channel name. Now that that is done, we can start working on our blend shape control. I'll slot this into my animation branch, and we're going to add some parameters to this node, so we'll open the type interface. We're going to have a lot more parameters on this node, and that is because we're going to use this node to animate our blend shape setup. We'll need a folder. I will have an operator path. This will be placed before my folder. I will have a button which will also be placed before my folder. Within the folder I will want two parameters. I'll want a float and I'll want a string. The first parameter we'll work on will be the operator path, and I'll call this target blend shapes. The name and the label will be the same. Within this operator path, we will refer to the blend shape node that we want to get our blend shapes from. This is also the blend shape node that we will control with this node. In this case, the blend shape node is Blendshapes 1. So I'll refer to Blendshapes 1 over here, and I'll set this with a relative reference. Next comes the button, and I'll call this button Update Blend Shapes. And I'll create a callback script for this button. The script will start with Who, which is for the Houdini library. There will then be a dot, and we'll be calling a function called PHM. This function will call a Python script which is placed on this node. This is a specific script which is called the Python module. I will not go into any of the details for the scripting, as this video is already going to be very long, and that is beyond the scope of this video. PHM will then be followed by two parentheses, another dot, and then we'll create another function. I'll call this function Update Blend Shapes, and it will be followed by two parentheses. So we'll need to create our Python module script, and we'll need to create our Update Blend Shapes function. I will go to the Scripts tab. I'll click on the Event Handler drop-down menu, and I will select Python module. This is what I was referring to with the PHM function, and I can place my Update Blend Shape function within the script. So it'll be def to define the function. The function's name will be Update Blend Shapes. There'll be empty parentheses, and then a colon. We'll then go to the next line, and I'll indent the rest of the script with a single tab. Python uses tabs to define its structure, so this has to be nothing more than a single tab. At this point, I only want to test if the script is working. So to test it, I'll type out print. This will be followed by two parentheses. I could actually print anything here, but in this case, I'll just print out update. I can then press apply to save the changes. I'll return to my parameter menu. I'll make sure that the name of the button is the same as that of the label. Once again, I can click apply to save, and then I can test my button. We should get update being printed in the console. Next comes our folder, and I'll call the folder Blend Shapes. The name and the label will be the same. I'll then change the folder type, and this will become a multi-palm block list. This will allow us to have an arbitrary number of the parameters that are in this folder. A parameter which is very important to set within this folder is called first instance. This will be used to determine the numbering of the items in this folder. Normally I will set this to be 0. This is because most programming languages start numbering at 0. However, in this case I will leave this parameter as 1. I can then start working with the parameters in my folder. I will call the first one alias. Once again, the name and the label will be the same. I will also make sure that this parameter is disabled by default. We do not want to be able to manually set this parameter. So I'll set disable when, and I will set this to be disabled when 1 is greater than 0. So I can apply, and we now have an option to add blend shapes. And if we add a number to our blend shapes here, we'll get a corresponding amount of parameters. We should be able to do this for most of the parameters we need, so we can add quite a few parameters to this interface. So the first parameter here is our alias parameter. I have made a mistake here. I've renamed the wrong parameter. This parameter should not be a float, it should be a string. So I'll select the next parameter and I'll convert it to a float. I will name this float blend, and the name and the label will be the same. So these parameters will represent each of our blend shapes. We'll have an alias, and we'll have the blend, which is what we'll use to control the blend shape. Currently the alias has a value. I will enter the alias channel and set this to have a default value of nothing. So we can now add as many blend shapes as we want. The alias will give us the name of the blend shape, and the blend parameter will control the blend of the blend shape. So that's our interface setup, and now we can start working on the functionality. So now we've set up our interface and we can start working on the script. And this is the script which is for our Update Blend Shapes button. So we can enter the Scripts tab and we can start working on the script. First I'll need a reference to this current node. I'm going to give a variable for this which I'll call node, and I'll set this with who.pwd. pwd is a Unix command which means print working directory and will refer to your current folder. However, in Houdini it tends to refer to the current node. The next variable we have will be our target, and this is going to be a parameter on this node. I'll set this with node.parm. So we're looking for a parameter on our node, and the parameter we're looking for is the target blend shapes. This is of course our operator path. I'll just test that I'm getting the correct parameter, and in this case I'll do that by printing target.name. This will give me the name of the parameter. However, in this case we do not actually want to just get the parameter. Instead we want to get the value from the parameter. So to get the value from the parameter, I'll use a method .eval. This will evaluate our parameter. So if I now print the value of target, I should get the relative paths to my blend shape node. I'll then use this value to get my blend shapes node. I'll store this in the variable blend node. We'll get this with who.node, and we'll be looking for our target. I'll then make sure this is working by printing the blend node. I should probably build in error checking at this point, but I will skip that for the moment. So now we've got our blend shapes node, and we need to know how many blend shapes this node has on it. So we'll be looking for the value of this blend parameter. However, we do not actually want every single value in this parameter, because by default the blend shapes node has one extra blend parameter, and this is the parameter for the original mesh. This will be blend 0, and this is the reason why we started our parameters at 1 rather than 0, since all the actual blend shapes on this node will have parameter names starting with 1. So we'll want to get this blends value, but we'll actually want this value with 1 subtracted from it. I'll create a variable for this called count. We'll look for a parameter on our blend node. We'll use the .parm method, and the name of this parameter is going to be nblends. We'll get the value of this parameter with .eval, and then we will subtract 1 from this. Once again, I'll check to make sure that I'm getting the correct value, and the value here should be 2. I now know how many parameters I'm going to be working with, and I can start looping over these parameters. We can also set the amount of parameters which we'll need on our blend shapes control node. So I'll set the number of blend shapes with node.parm. The parameter we're going to set is the blend shapes. We will then use the set method, and we'll set this to equal our count. I can now test. We should have the same amount of blend shapes as we have in our blend shape node. We can now loop over these parameters. For I in range, we want our range to start at 1, and we want it to end with our count, but since we've subtracted 1 from our count, we will add 1 to it here, so this will become count plus 1. The first thing that we want to do within this loop is locate the parameters on the blend node itself. In this case, we'll be looking for our smile and our eyebrow parameters. However, smile and eyebrows are the aliases, and in this case we'll be accessing them with the parameter names, and those names will be blend1 and blend2. So we'll create a variable for this, and I'll call it target blend. And this will be a parameter on our blend node, so blendNode.palm, and the parameter's name will be blend. We'll need to add our number to the end of this name. The easiest way to do this is to use Python string formatting. We can do this by putting a lowercase f before the string. I'll then add in curly brackets where I need to add in my value, and this is where I'll pass in the value, and in this case the value will be I. I can now print out my target blend parameter. So I test my script and it doesn't work. In this case it's because the blend should be spelt with a lowercase b. I test again and I'm getting my parameters, which is exactly what I want. So now that we've got the target blend parameters, we can start connecting up our parameters on this node. I'll start with my alias. First I'll get the parameter with node.palm, and the parameter's name is alias. And once again, this will be a numbered parameter, so these will be alias1 and alias2. So we'll format the string. Alias will end with curly braces, and I'll place my I here, and I'll place a lowercase f before the string. So we now have our parameter, and we're going to set its value, and we'll set this with targetBlend.alias. We can now run our script again, and our alias is now being set with the name of the slider. This will also correspond with the name of our blend shape and the name of our blend shape channel. We'll be using this to update our attributes later. So the next thing that we want to do is we want to drive the parameters on our blend shape node, and we want these to be driven by our blend shape controls node. So basically these blend parameters will be setting a relative reference on the blend shape parameter node like this. The advantage of doing it this way is we'll keep all the nodes which are controlling animation closer together, and we can hide the functionality which the animator does not need from the animator more easily. So to set this, I'm going to start by creating another variable, and I'm going to call this variable relative path. In this case I'll abbreviate it to relPath, and I want to find the path of my control node relative to the path of the blend shape node. So we'll perform our calculation using the blend shape node. Blend node dot relative path to, and we want the relative path to node. I can then print this to make sure it is working correctly. To make this easier to read, I'm going to calculate my path in a separate variable. So this will be target path, and this will be a string for the path that I'm wanting to set. There'll be a lowercase f to format a string, then the quotation marks. I'll place curly braces to insert a value, and the value here will be relPath. We'll then have a backslash, and this will be relative to the blend parameter, and we'll need to insert the number of the blend parameter. So there'll be two curly braces, and the value I will go between these braces. We can now create our final expression. This will be done on the target blend parameter. So target blend dot set expression. Once again, this will be a formatted string, so it will start with a lowercase f, and then I'm going to need to set this with single quotation marks. We'll then be referring to a channel with ch, and this will require parentheses. I'll then place curly braces within this channel, and I'll pass my target path into them. I can then apply and I can test. And if we take a look at our parameters, we'll see that they've been set, but they've not been set correctly. This is because the value within our channel function needs to be a string. So we need to place our quotation marks here explicitly, and that is one of the reasons why we're using single quotation marks here, is so that the quotation marks will register correctly within the channel function. So now if I use my button to update this again, we'll see that our blend parameters are driving the parameters within the blend node itself. So currently my blend parameters are actually too large. They can also pass into the negative. I do want to be able to set these parameters as negative values, but I also want to make sure that the range is more constrained. So in the parameter interface, I'll set the blend parameter to have a range, and this range is going to be from an unlocked 0 to an unlocked 1. We now have a more sensible range for our sliders, but the animator can go beyond this if necessary. And we've now set up the basic interaction for our sliders. We no longer need to interact with this part of the network at all. We can control everything with these nodes over here using the sliders. So next we're going to need to add our functionality to this node, where we actually add in the attributes to store the channels and the animation. And we'll do this with an attribute wrangle node. We can now start working on this attribute wrangle node, but I've forgotten to add something to my Python script, so I'm going to fix that first. So I'll open my type properties. Before I update the script, I'll make a small update to the blend parameter. I'll set the label of the parameter to be %s. If we apply that, we'll see that the label changes and now shows the actual parameter name and not the label. So instead of saying blend, it says blend 1 and blend 2. That, however, is not what I want these labels to be, and this will underline what I have forgotten. I have forgotten to set the alias for these sliders. Another thing which I can do is for the alias, I can duplicate the conditional from the disable when field and place it into the hide when field as well. This will hide the alias parameter from my interface. The main point of the alias parameter is to store information in any case. I can now open the scripts panel again. There is one last thing which I need to set here. I'll perform this after I set the value for the alias parameter. We're going to update our blend parameter, so we'll get the parameter with node.palm. The parameter which we'll look for is the blend parameter. I can then set this parameter, and I'll set this with targetBlend.alias. But instead of setting the parameter, what we want to set here is the alias. So instead of using the set method, this will be the setAlias method. I can now apply this, and I can run the script. You'll see that my blend sliders now have the same name as the blends that they are setting. So now the parameter blend 1 will show up as smile. The same will apply for blend 2 with the eyebrows as the alias. This also means that I can refer to these channels specifically by their alias in the attribute wrangle, and this will allow us to simplify some of the more complex parts of the attribute wrangle script. It also makes these sliders far easier for an animator to deal with. I'll apply the changes to my HDA, and I can now start working on the attribute wrangle properly. The first thing that I'm going to do is I'm going to import a library. So this will start with a hash, include, then we'll put the library's name between quotation marks, and the library will be KineFX _channels.h. I'll set this attribute wrangle node to run over detail attributes. I'm then going to add a print statement to use for debugging. Printf will then have quotation marks. I'll add a \n so we add a new line every time we print. And I'll add a wildcard which will be %g. I'll leave the second argument open for the moment. I'll add my first variable and I'll call this variable count. This will be an integer variable, and this variable will store the number of channels we'll be working with. To set this, I'm going to use a channel function, and I'll be explicit by using chi for integers. And we will want to make sure that we're looking for the channel in the parent of this node. So we'll use .. I'll then open my parameters so we can see which channels we're looking for. And the channel we'll be referring to over here will be my Blendshapes parameter. So the final argument will be .. Blendshapes. I can then set the argument of my print statement to be count, and I'll make sure that I've added in my semicolons. We now have a count of 2, and we can use this to loop over our channels. The next variable we'll create will be a dictionary. This dictionary will be used to store the animation information for our blend shapes. So this is a dictionary, and it will be called channels. Next we'll want to make sure that we do not already have an attribute that we'll be overriding. So if there's already animation stored for blend shapes, we do not want to override any existing information. We will have a conditional if, and then we will use the function hasDetail attribute. The input will be 0, And the attribute that we're looking for is the attribute we use to store our animation for our blend shapes. And this attribute is clip channels. So if we have a clip channels attribute, we will add the existing animation from this attribute into our channels dictionary, and this will prevent the information from being overwritten later in the script. So channels will equal d at clip channels. So now we'll loop over all of our blend shape parameters, and we'll store these parameters in detail attributes. We will do this in a for loop. For int I equals 1. Once again, the names of the blend shapes start at 1. We will check if I is less than or equal to count. This will allow us to loop up to and including the count number. In this case, the number would be 2. Then we'll increment with I++. I can then test my loop by printing out I. I'll need to fix my syntax errors. I've used a comma instead of a semicolon. So next we're going to need to get some information. And what we'll need to do is get the alias. And we'll need the alias so that we can both have the name of the channel we're setting and so that we can access the value from our blend parameters. And this is specifically why we created parameters to store the alias. So we'll store this in a string variable. The name will be alias. We'll have to generate our string as part of the for loop. So to do this, we'll use the sprintf function. The string will be alias, and I'll add a wildcard %i, as this will be an integer value, and we'll set this with the integer from our for loop with I. We can now print our alias, and we're getting alias1 and alias2 printed. However, we'll need to look for the parameter itself, and the parameter is actually on our parent node. So we'll need to look for the channel, so we'll have CHS for a string channel. So once again, this will be looking for an alias string parameter, and we don't want to look for the alias itself, we want to look for the alias from the parent. So this will be ... then alias. And if we now test this, we'll get the names of our channels being printed out. We're now going to store our blend sliders as detail attributes. To do this, we'll call the function addDetailAttrib. The first argument will be 0 for our first input. We'll then need the name of the detail attribute, and we'll set this with our alias. Then we will set the default attribute for this detail parameter, and this attribute needs to be set as a float. So I'll set this at 0.0. We need to do this to guarantee that it is a float. If you do not put it in as a float value like 0.0, you could spend hours debugging this and not know that your detail channel has been set as an integer. And if this channel is set as an integer, we will not be able to store any of its values. We can now take a look at the geometry spreadsheet. We're generating a parameter here for each of our blend shape channels. These values will be used to drive the blend shapes that are stored within an FBX. Next, I want to set these detail attributes so that they contain the current values of our sliders. So we'll use the setDetailAttribute function. We'll use the first input, so it will be 0. The name will be set with our alias variable. Finally, we'll have our value, and we want to set our value with our slider. So we'll be looking for a float channel, so CHF. We're going to create our string with sprintf. This will be part of our parent node, so we'll need ... I'll then add my wildcard, which will be %g. I can then pass in the name of the slider, or in this case the alias of the slider, with the alias variable. The final parameter will then be set, because we are setting the attribute. I'll correct my errors, I've forgotten a bracket. Now we should see our detail attributes updating dynamically based off the sliders. The final thing that we'll want is to be able to store these channels as animation. So in other words, we want to be able to store the information for the channels in this dictionary. We'll then want to store that as a detail attribute. To do this, I'm going to use a function from the KineFX library. This will be KineFX _ add channel detail attrib. The first argument will be our channel dictionary. The next two arguments will be strings, and they will reference the name of my channel, and the value of my channel respectively. In this case, using the same naming for all my BlendShape attributes simplifies this greatly, and I can set both of these arguments with my alias variable. I can then register the dictionary's information in an attribute. This will happen after the for loop. This will be a dictionary attribute, so it will be d@, and it will be the clip channels attribute, and I'll set this with our channels dictionary. And in my geometry spreadsheet, I should now see a dictionary attribute which is storing the values for both my smile channels and my eyebrows channels. And this should store any animation which is currently in these channels. So we should now have two nodes which we can use as a complete system to animate and export our blend shapes. So now I'll need to export my blend shapes to make sure that this is actually working. I will also probably have to deal with one or two bugs before that happens. In order to test this, I'm placing some basic animation on my blend shapes. We should now have some basic animation set up, and I should be able to see the result of this if I set the display on my bone deform node. So I can now try and export my animation. I'll start with the animation export, and when I save to disk I have no problems. I then do the same for my character export, and I get an error. This is a missing name or path attribute, which means I don't have a proper name attribute on my mesh. Basically in this case it means that when I've set my name, I've left it at points and I have not changed it to primitives. I check again, but I've forgotten to update my stash node, so I get exactly the same error. I update the stash and I try again. I now get another error, and this is a different error, and the error says that we cannot create the name for the primitive 374. So I'll assume that this is happening where I'm creating my blend shapes, and I'm just going to check if my default line needs to be set as packed primitives as well. In this case I'll make sure that I transfer all of the attributes to my packed primitive. I try to save again, and I still get an error. In this case it's exactly the same error, only it's referring to the error being on primitive 1. Now because I've packed all three inputs, there should actually only be 3 primitives. Since the index should start at 0, that means that the problem probably lies in my blend shape primitives. So if I look at my geometry spreadsheet, we'll see that we do only have 3 primitives, and that currently neither of my blend shape primitives are storing the name attribute of the mesh. So I'll take a look at my blend shapes create node, and we'll take a look at the pack node, and here I'll transfer the name attribute to the packed primitive. I'll then save the node type to make sure the node is updated properly. I can now try and save again, and I have no more errors, so that has fixed the problem. So my issue here was that not everything had a primitive attribute for the name. I will then bypass the pack node for the default geometry. So our problem was that we weren't correctly transferring the name in the blend shapes create node. So we should now be able to export our blend shapes. So I'll save to disk, and I'll make sure that everything is exported. And then I want to test that this is actually working. I'll return to the object level and I'll get a geometry node. I'll start by getting an FBX animation import. We'll also get an FBX character import. I'll then load the FBX file for my character, and I'll load the FBX file for my animation. So for my animation, we can see that I'm importing my skeleton, and that the animation is applied to the skeleton. I can then get the character blend shape nodes for the character, and I'll connect this to my character FBX. I'll get a bone deform node, and I'll connect this up as well. So everything shows up, but if I scrub through the animation, we'll see no animation showing. I can connect my animation import to the bone deform node, and we'll see that the skeletal animation is being recorded correctly. So for our character, we're storing the character, and for our animation, we're storing the bone animation, but we're not transferring any of the blend shape animation. We should, however, check that we're storing the blend shapes correctly before we check what is wrong with the animation. So I'll get my attribute expression node. This will be connected to my animation path. we'll be looking for a custom attribute, and this will be a detail attribute, and we'll be looking for a float attribute. We'll also want to set the attribute, so to set it we'll make sure that the expression is being set by value. I will then look at my attribute name dropdown, and my blend shape attributes are showing. So the blend shapes we have are our eyebrows and our smile. I'll start by looking at the eyebrows, and when I move my slider I get my eyebrow blend shapes, so we are transferring the channels and we are transferring the blend shapes correctly. And when I check the smile, that is working as well. So what we can confirm is we're saving the FBX, we're getting our materials transferred, we're getting our blend shapes transferred, and we're getting our blend shape channels transferred. And when we're saving the animation, the skeletal animation is being transferred. So we're transferring everything we need for the blend shapes, but we're not getting the animation. And there is a simple reason for this. And that is we actually cannot store the blend shape animation in an animation export. This node will only store animation for the skeleton. The blend shape animation needs to be stored with the mesh. In this case, I'll use the most straightforward method of solving this, and I'll just copy the blend shape control node, and I'll connect it directly to the export. We should do a more complete setup, but as an example, setting it inline like this will work perfectly fine. I'll save to disk, and I'll return to my examples. I will then reload the animation in the character animation node, and now we'll see that we have the animation for my blend shapes being exported correctly. So we have our animation working and we have our blend shape animation working. You should just take note that when you want to export blend shapes with the animation, that should be exported as an entire character animation. So the final thing to do is to check our export and import in an external application. In this case, I'm going to use Unreal. I will drag and drop my FBX file for the character into the content browser. We should then get the import dialog, and there's a couple of things which we'll need to make sure are set in this dialog. I'll need to make sure that import morph targets is correct. If this is not checked, we will not import our blend shapes. Then I'm going to make sure that I'm not importing a skeleton. If I'm using a skeleton that does not match up with the bones which I have in the current mesh, it can cause issues. So if this is the first time you're importing a character, it is best to make sure that this is blank, and Unreal will create a brand new skeleton for this character. Apart from that, I'm going to leave the import to use the default parameters. I can import and we'll get some warnings. Most of these are not that important. For example, it will say I've got no smoothing groups. Smoothing groups are related to 3D Studio Max, so it does not really matter. Although in this case I haven't set up my normals properly, so that is an issue. Then I'll get a warning that my effector bone is not being registered as part of my weights. This is also not that important at the moment. The next problem is that I have not set UVs. For a proper character I would definitely have UVs set. And then we have a warning about the automatic physics creation. This is something we can always fix manually, and we'll generally want to customize something like the character's physics in any case. So we'll see that my mesh has been imported, and that it has automatically created an animation for this mesh. We've also imported the materials as basic colors. Generally with FBX, I do not expect anything more than the importing of colors and textures. We would want to set up the materials specifically for Unreal in any case. And then we have our generated skeleton. Next, I'll examine the animated version of the mesh. If I click on this mesh, we can take a look at the result. This will open the blueprint, and we'll see that I have the animation for my character registering properly here. I could add this animated version of the mesh to the scene, and we will get the correct animation. Next, I can test the importing of my animation. Over here, we'll see that it tries to associate my animation with my skeleton. In this case, the skeleton is correct, so I'm not going to change it. Since this is purely animation, I will not change anything else, and I'll import my animation with the default settings. I should now have two animated meshes. I can make sure that both of them are brought into the scene, and I can press play. And I now have both my skeletal animation and my blend shape animations being imported into Unreal separately. although that doesn't really help the lighting setup. So that will cover a setup for exporting blend shapes. As I said, unfortunately, exporting blend shapes in KineFX is extremely complex, but hopefully this will give you some ideas in how to simplify the pipeline.